So you fire an arrow, maybe it hits the target. Wait, did that one just pass through it? No impact, no sticking, no collision? I could come back and increase the size of my collision area on my arrow, but the result still isn't perfect. Like, why are my arrows sticking through objects and walls? They should be hitting at the tip, right? Well, this isn't a bug in my game logic. This is a common physics problem with fast-moving projectiles. And today, we're fixing it. Now, I've already gone through and fixed this and figured out the way to make this work and done quite a bit of research. But you can see now that my arrows are going to stick right on the tip just like I want them to, and I'm not going to have any of those weird collision issues that we were seeing before. So there are several ways that we can fix this, and I'm going to explore the various different options so you can choose the one that fits your game and maybe your coding and learning style the best. All right, so I've got a demo here, and we're going to talk about these different types of bullets, but I want to start with the first one. You can see here we've got a discrete collision, which is an area 2D. Now, this is generally how most people will set up their bullets, especially if you're a beginner. And honestly, this is fine if you've got slow-moving bullets. And this is how my arrow was set up in the example. So my arrow had an area 2D, and it was detecting for collision, meaning if it overlapped any kind of shape that it should collide with. But you can see that it's prone to tunneling. But let's go ahead and just look at one of these bullets. And that seems to work fine. But as soon as I increase the speed of this bullet, let's try maybe 4,000. You can see it goes right through that wall, okay? And it looked like it passed through the wall there for a second, but one thing that's happening is I do have interpolation happening, so my physics frames skip that wall completely, but it's still drawing the visual frames in between. But yeah, we don't want our bullets to pass through. Let's try half the speed and see what happens. Okay, working better, but it's still not hitting the wall until it's in the middle of it, right? Ideally, what we want is we want the bullet to be like one of these down here, perhaps, where it always hits the wall, no matter how fast the bullet is moving. So if I increase this back to 4,000, you can see that these two bullets down here both hit the wall, regardless of the speed, whereas this one will pass through. I mean, we could even add another 0 onto this. And these things are so fast we can't see them moving, but they're still hitting the wall, okay? So how do we make something like this work, and what are the different ways that we can design and build our bullets? Let's start by looking at the discrete collision, which is the area 2D that we discussed. Okay, so you can see here I've got a simple bullet. It's built inside of an area 2D with a sprite as a child, and here's the collision shape. And how an area 2D works is as it travels across the screen or through your game world, it just checks for collision, and anytime it finds it, like in my script, if it enters another body, I have it play an explosion by instantiating an explosion node and positioning it at the location of the bullet. And then I have it cue free itself, okay? Pretty straightforward. Now, if I go to my sample scene, and let's just drop one of these in here. To demonstrate what's happening, essentially the bullet is moving at a specific rate, right? And so let's assume it moves about this far per frame. You can see there's a potential for it to totally pass this wall. If the bullet were moving this distance, and of course I'm not doing it scientific, it's not perfect, it has the potential to totally miss the collision. Now, this is sometimes referred to as tunneling. You can, of course, increase frame rates and do things like that, but maybe you're targeting lower end devices like a mobile device, and you don't really want really high frame rates on your physics process because it's expensive, right? So the best you could hope for is maybe to cut it in half, but still you're going to have this situation where the bullet's going to hit here in the middle of the wall. This option just isn't good if you need high-speed bullets, or if you really need to limit your physics detection. All right, so the next one I want to talk about is actually a little bit different, because we do have the potential that we can avoid this altogether by just detecting if the bullet should hit a wall. And so the first alternative to this discrete collision or an area 2D style collision is to do a hit scan. And what a hit scan means is we're going to cast a ray in the direction that the bullet should be traveling and detect what it hits. Now, this is really good, especially if you're doing like a 2D game. This is going to be for guns that are going to have such a fast bullet time that it feels and appears instantaneous. So if you've got like a rifle, sniper rifle, lasers, or those kinds of projectiles, then you may just want to do a hit scan, and you don't even need to draw the bullet in this case. You just draw the collision when it hits it. So let me show you what this looks like. So my hit scan, I'm just going to cast a ray and draw an explosion where it hits, okay? And this can be rotated, and you can see right here is my ray. You see this ray cast? It's just drawing in a line. But I mean, you could cast a ray in any direction. If I were to cast up here, you could change the direction based on the facing of your character. Then you can see that when I click that, it collides up there. Okay, instant collision. So that's one option. So let's look at how we can set this up to work. So you can see I've got a raycast 2D here. It is disabled, or it's not enabled, right? Which means it's not detecting collision. If I were to turn it on, then you could see if it's colliding or not. But really what I want to do is I just want to detect collision only when I fire the bullet. So that's why I've disabled it. The target position here in X and Y coordinates determines this endpoint, and that's pretty easy to update in code if you need to. And then I simply have my collision mask set to the layers that it should be able to collide with. In this simple example, layer 1 is where all of my collidable shapes are, so that's all I need to check here. Now with a raycast, you can configure it to also collide with areas, but by default we're only colliding with bodies. Then looking at the script, all I'm doing here is I'm forcing my raycast to update. And the benefit of doing this force raycast update is that it's going to check immediately. It's not going to wait a frame to see if it collided. It's going to do it right now. And then we can say, okay, if it's colliding, then we'll get the collision point. And you can see I'm printing this out to the console here. So in my examples, it was printing that collision point right there. And then I'll just spawn an explosion at that location. And of course, you could do other things like check if the node that it collided with is something that could take damage, etc., and handle that appropriately. So this is a really straightforward way if your bullets don't actually need to travel. You simply instantaneously cast a ray and update the collision as is appropriate. Okay, but what if you actually want to see the projectile, right? Like the example I've got here. We want to see the little ball flying. We just don't want it to tunnel through things. Or in the case of my archery game, I want arrows. I want to be able to see them. I've got two different ways to handle this that I'm going to cover here. One involves a different type of collision, so a character body 2D instead of an area 2D, while the other one will use raycasts, but in a different way than we've done previously. And so I want to talk about both of them, but these both achieve the same end goal. And they use a technique that essentially sweeps or checks the area that the bullet will have traveled during that frame to see if it should have collided earlier. So what I mean by that is as the bullet's traveling, even if it were to skip from point A to point B, what a sweeping technique does is it's going to check to make sure it shouldn't have collided previously. And if it did, it's going to stop it where it should have collided. Okay. So the code is smart and knows that. Now, the thing that's nice about a character body 2D is that this is a native type of collision body in Godot, and that tunneling logic is built into how the node works. And so for fast moving bullets that need a physics response like this, you would consider using a character body 2D. This is also really good if you're going to do things like ricocheting or bouncing. I would highly recommend this option. And it's going to prevent tunneling altogether. So let's look at the example of how I built this. First off, on my button press, all I'm doing is instantiating an instance of my bullet character body, which is this type of character body 2D bullet. I'm setting the position and the speed and just adding it to the scene and letting it do its thing, okay? So nothing too fancy there. So let's go ahead and look over at the bullet now. Now, this bullet looks just like the Area 2D bullet, but you'll notice a few things that are different. So we've got the same collision shape size. Our collision is set to the same layer, but this is a character body 2D. Now I've set the movement mode to floating, but this would work either way if it was floating or grounded. Okay, so you don't have to change that, or you should just change it appropriately to fit your game type. But let's go ahead and look at the script logic on this. So this bullet, as soon as it's created, I'm just connecting to this visible screen notifier so that once it leaves the screen, it destroys itself. You don't have to do that. That's an optional step. But all it has is a physics process where I'm detecting collisions each frame. And so in order to do the functionality that I've built here, we're using the move and collide function, which is part of a character body 2D. And if we look at the move and collide, it moves the body along the vector motion, meaning you tell it of vector 2 and it moves it in that direction. And in order to be frame independent, it says we have to make sure that we use delta, and I'll return to that. And then what it does is it will check to see if it collided. And like I said, that tunneling, that sweeping detection is already built into this. Now, this doesn't detail how the sweeping works here in this documentation, but it does, and the proof will be in the pudding, right? So if I go back to my character body 2D bullet, you can see that I'm moving it in a direction, which is a vector 2. And by default, I'm setting it to the right direction. So you could just change this when you instantiate it. And then I'm multiplying that direction by a speed, which is by default set to 400, but I'm using that little UI in my scene to modify that. And then I also multiply it by delta because a speed is like, pixels per second. But of course, this physics process is going to happen 30, 60, maybe 120 times per second based on how your project is configured. So once we calculate the direction, the distance that it moved, and for how long it moved, we just pass that into the move and collide. And then this collision that the move and collide returns will just tell us if there are any collision shapes that it hit. And so you can see I'm just spawning my little explosion animation node, positioning it, adding it to the scene, and then I'm Q-freeing the bullet. Okay, so the bullet's gone at this point, but the explosion stays. So then what that looks like, even if I have a really fast bullet, when I use this character body 2D, it's still going to collide, whereas this area 2D is going to pass right through. Okay, and I have my project set, by the way, to 30 frames per second in the physics process, but it's rendering much faster because my screen refresh rate is 144 hertz. So that's why you might see a little bit of appears like it should be colliding here, even though it's not. Okay, so there we go. But let's look at this other raycast 2D version of swept collision before we wrap up, because this is the one I opted to use for my arrow. And I think as I show you and explain how it works, you might understand why. Okay, now conceptually, this swept collision with the raycast 2D that I'm going to build is hardly any different than the swept collision using a character body 2D. And in fact, I don't know the ins and outs enough to be able to tell you if it's more or less performant. I believe it's slightly more performant, but for most games, it's not really going to make a difference. But what's nice about the swept collision with a raycast 2D is there's a little bit more insight into what is happening, but you can also use any kind of shape cast you want. And so if you wanted to simulate something like a shotgun shot with a spread, then this might be a good way to handle that. But I'm going to stick to a simple raycast instead of a shape cast because it's the simplest, most efficient way to handle this. And so once again, I've got a bullet. Now, the difference with this one is this is a node 2D with a sprite, and there are no collision shapes involved in this one. Instead, I have a raycast 2D here. So much like the raycast that we had in our other example, you can point the direction of this raycast any direction you want it to travel. Now, the difference is in the first example with the raycast, we were casting a ray that would cover the whole screen, right? In this example, what we're going to be doing is we're only going to be casting a ray that travels in the direction and for the distance that the bullet will travel on any given frame. And then we'll just check for that frame, would it have collided at any point? So looking at my script here, of course, I've got my explosion that I'm going to spawn if I hit something, the speed, the direction. These variables are basically the same. And then I've got a raycast along with my screen notifier. Again, I'm doing that little thing just to free the bullet when it leaves the screen. Now, the code on this one is a little bit longer, but it's not so daunting that it's overwhelming, right? Essentially, what we're doing here is for each frame, we calculate the change in the position, which is essentially the same thing as the code we saw in the previous one. So this is a vector 2 where we take the direction that the bullet is traveling in, multiply it by the speed and by the delta, okay? This is the exact same value that we passed into this character body 2D. But we're storing it here as a variable. I'm calling it position delta, meaning the change in the position. But before we move the bullet, we want to check to see if it should have hit anything. So here we have ray.targetPosition equals position delta. So in other words, we're taking this and we're saying, okay, your target position is here. If it's moving, let's say it's moving 100 pixels this frame to the right, then it's going to look like this. It's going to be 100 to the right and 0 up or down. Now, if it were at an angle, then it would be something more like that, right? But essentially, we're just setting that. Back into our script, we'll use this ray.force raycast update, which is going to force the raycast to update on this frame and tell us if it's colliding. And so then we can check if it's colliding or if it's not. Okay, in the simple case where it's not colliding, we just update the global position to be that new point where the ray was pointing at because it didn't find any collisions in its path. But if it is, then what we do is we will set the global position of the bullet to the point where we found a collision, because this ray.getCollisionPoint is going to return us a vector 2 in the global coordinate system, which identifies where the raycast hit another object. So we can simply move the bullet partially along the path instead of to the very end. And then, like normal, I'm going to spawn an explosion at the position that this bullet is, add it to the scene, and then cue free the bullet, right? So really all of this is just extra window dressing, and all the magic is happening in these lines here and down here. So this one's really straightforward, and it gives you a little bit more knowledge and control over what might happen, okay? So I think the difference between the continuous raycast and the character body raycast are slightly more coding for the raycast. But as I said, if you wanted to convert this raycast to a shape cast and check for various different types of collision, you could do so. And in fact, if you do a shape cast, you're probably basically recreating how this character body bullet works, but you know, it's fun. I'm going to go ahead and just run the scene one more time, and let's demonstrate this last one. There is one difference that you'll notice, okay? And that's the location of the explosion. Now with this character body 2D, the bullet is hitting on its edge. And in fact, if I slow this down, you'll see what I'm talking about. So the first bullet, boom, it collided as soon as it hit. This one collided when the middle hit, because in our script, we're casting this ray from the center. And so the collision, when we move, is going to move it to that central position. But I think that's okay for certain types of bullets. Okay, so let's look at how I implemented this in my little arrow example. So here, I'm using a raycast 2D to just detect the collision from the arrowhead, the point at which I want it to collide. Now I bumped it in a few pixels so that it would stick into a wall as opposed to sticking at the point. And then I just have that same kind of logic with this arrow to see if it's colliding with anything. So I'm going to go ahead and turn on my visible collision shapes and run the project. And you'll see that the arrow, wink, you've got that little red line at the front of it. And you see I killed the dude over there with that arrow as it was returning. You can see the little raycast moving with the arrow. And when I shoot it really short, that raycast is a small blue arrow. But when I shoot it really fast like this, then you can see it was a little bit longer, right? And of course, that's going to vary depending on the frame rate that you're getting in your game, because the delta is going to determine the length of that arrow. So if your game is having sluggish performance, these methods are still going to work. You're not going to have tunneling. They'll still detect collision at the point you want them to. Well, thanks for watching. If you guys have any questions, then go ahead and drop them in the comment. Otherwise, if you're new, go ahead and subscribe to my channel so you can see when I release more videos. Now, I am working on lots of different video content, but primarily I have some long-running series right now. That's the Metroidvania Forge series. So if you're interested in that, go ahead and check that out, linked in the description below. And otherwise, we'll see you next time.